Hey everybody, we will get started here in just a couple minutes. I'm going to give a little bit of time for everybody to join. All right, let's go ahead and kick this off, everybody. Welcome for thank you for joining. My name's Chris. I'm one of the co-founders of MassDriver, and I'm going to be the host for today's webinar. MassDriver is a visual tool for deploying, managing, and observing your cloud resources and applications, and we'll be using it a little bit in today's webinar. But if you're not familiar with MassDriver, that's okay. This webinar is going to be for anybody who is operating in Amazon with EKS and is interested in KubeVirt. We also have other members of the MassDriver team in the chat and Q&A rooms. So if you have any questions, feel free to ask it, and we'll try to answer it in chat or even on air. This webinar is also going to be recorded and it will be uploaded to our YouTube channel. So if you jump in halfway or if you have to leave early, you can go and check it out there afterwards. So today we're going to be talking about a tool called KubeVirt, and we're going to be deploying it to an AWS EKS Kubernetes cluster. Now, this will be a beginner level tutorial. It's just going to be about getting KubeVirt installed and getting a VM up and running. But it is going to touch on some complex subjects within Kubernetes. We'll try to isolate that. And again, we're not going to try to get into too much of the complexities of it. We just want to give an easy demo and show what KubeVirt can do. So for anybody who's following along, I'm going to share some links in the chat. The first link here that I'm sharing is actually going to be the materials for this webinar that we're going to be going through today. This second link is for the actual KubeVirt website, the official website for the KubeVirt tool. So if you're interested, you can check it out there. There's lots of documentation. We are going to need kubectl or kubecontrol or kubectl, whatever you refer to it as. It's the CLI tool for Kubernetes. And the last link that I'm going to share here is actually a official KubeVirt tutorial that they have on how to do basically what we're doing today, which is going to be getting KubeVirt up and running in EKS. We're going to be following it, I'd say loosely. We're going to tweak some things specifically to make it show how it works for Kubernetes and to show where you can configure and change it. The last thing to note, this webinar obviously requires a running Kubernetes cluster, and in our case, specifically an EKS cluster. If you don't currently have a cluster, you can head to massdriver.cloud, and we have some bundles that you can use to get up and running very quickly in actually any of the major clouds, AWS, GCP, or Azure. But these clusters take about 15 minutes to deploy, and that's not us. That's just the clouds take a little while to bring those things up. So if you don't already have one running to follow along today, you probably don't have time. But again, we are recording this webinar, and so you can follow along with the materials in that first link, which is what we're going to be using afterwards once you have your Kubernetes cluster up and running. So having said that, let's go ahead and get started. So first, let's talk about what is KubeVirt. So to put it as simply as possible, it is a technology that allows you to run VMs alongside containers in a Kubernetes cluster. Most of you guys are probably familiar with Kubernetes. It's a container orchestrator, but it natively has no ability to run VMs. Ironically, it uses VMs for the nodes to run the pods. What KubeVirt allows you to do is actually run VMs alongside all of your containers. And so that's what we're going to be doing today. We're going to be bringing up a VM alongside all of our container workloads. KubeVirt is officially a CNCF incubating project, which if you guys aren't familiar, that's the Cloud Native Computing Foundation. A lot of the major tools that you see with a lot of adoption, open source tools like Kubernetes, like Prometheus, and we could say like KubeVirt, those are all CNCF projects. And the fact that it's an incubating project means that it's demonstrated a significant amount of activity, usage, and stability, enough so that it's kind of one of the more official projects within CNCF. For those who are familiar with OpenShift, KubeVirt is actually what drives the container native virtualization. And it's not just, KubeVirt isn't just used, even though it's in the Cloud Native Computing Foundation, it's not just used in clouds. It's actually common to use in data centers to manage VMs. And so it can be used on premise as well. It doesn't have to be used in the cloud. So why would you use it? What are the benefits of using something like KubeVirt? Well, some apps just don't fit well into containers. For whatever reason, maybe based on the runtime or some of the requirements or the size of the application, whatever the reason, if it works better, if your application works better as a VM, what KubeVirt allows you to do is keep it as a VM, but but also be able to run it in the same environment as all of your other containers. So particularly if you're in a situation where you have VM workloads and container workloads, KubeVirt is something you should probably consider whether or not it fits your organization. It allows you to unify tooling around Kubernetes. So if you had a split environment where you were doing some things in Kubernetes, some things in VMs, you likely have to manage now double the sets of tools, because maybe you have different tools for how you're managing VMs and different tools for how you're going to be managing your containers. And you can unify tooling around Kubernetes specifically if you're using something like KubeVirt. The last thing is, I'll mention that, for those who weren't aware, Broadcom acquired VMware late last year. And that acquisition, let's just say, wasn't without some issues and complications. And so there are some, perhaps even many VMware customers that are looking for alternatives to see if there's other ways that they can manage their VM workloads. And the good news is, since KubeVirt is a part of the CNCF, it makes it very unlikely that the roadmap of issues and priorities and features and things like that is going to be governed by anything other than users and what is best for engineers. So that's one of the benefits. So let's talk about what we're going to be going through today. Actually, before we jump into that, let's talk about the objectives, and then we'll get to deploying the Kubernetes cluster. So the first thing that we're going to do is we have to get our Kubernetes cluster ready to be able to run KubeVirt. One of the requirements for KubeVirt is it needs bare metal nodes. you can't just run this on normal VMs. You can't run a VM on top of another VM. Now, that may or may not be possible, but in KubeVirt specifically, bare metal nodes are required. So you do need to go and probably check whatever region you're in to see what the availability is of your bare metal nodes. And also be aware, it's not cheap. Bare metal nodes are not cheap at all. A lot of the other VMs are cheaper because you can get fractional instances because they're taking a bare metal node and breaking it up into smaller VMs. So you can buy, 2 CPUs and 4 gigs of RAM or something like that. With bare metal, you're buying the whole machine and you're renting the whole machine. And so in our example, we're going to be using a C5 metal, which is one of the more common ones. It's 96 CPU and 192 gigs of memory, and it costs $4 an hour. So understand that this demo, if you bring it up and take it right down, it'll only cost you, probably $10 or less. But do be aware that that is one of the issues with if you're going down this route is that you can't buy fractional metal, at least in AWS. So after we get bare metal set up, we're going to be installing the KubeVirt operator, and we'll talk about exactly what that means later. Then we're going to be deploying a VM onto that bare metal instance using Kubernetes and KubeVirt. So to get started, we need to set up our Kubernetes cluster with bare metal nodes, and we're going to be doing a lot of the provisioning through MassDriver. So let's jump over into the MassDriver console, which I have a custom project right here that's set up and it's ready for us to go. We have our Kubernetes cluster, and we're running in a VPC that I'm managing elsewhere. That's why it says remote reference there. So let's configure this Kubernetes cluster right here. And if I scroll down to the node groups, you'll see right now we just have a T3 medium node group. Let's add a new node group here specifically for bare metal nodes. So let's name it metal. And for the instance type, I've actually tweaked this as a slightly customized version of our EKS bundle. All we've done is added this C5 metal node group or instance type, I should say, as an option in deploying this. So do be aware that if you want this bare metal option, you can just fork our bundle and tweak it to add whatever node groups or instance types you want, including bare metal. So we're going to do that just to ensure that we're saving costs. We're going to reduce that maximum size down to 2. There's no real reason this should ever go above 1 anyway. And for advanced configuration, this is where we're going to be able to apply taints. And we'll get into exactly what taints and those things are. We're just going to say VM equals true. And I'm going to kick this off to get deploying just because it takes a few minutes. So let me click deploy. So that's going to now go off to our provisioning system, and we're going to update this cluster. And here in hopefully a few minutes, I think it takes 3 or 4 minutes, we should have a new bare metal instance running in that Kubernetes cluster. So let's now jump back into the slides while this is executing and continue kind of talking about what we're going to be going through and doing today. Okay, so terminology. Let's talk about some of the terms that we're going to be using, hopefully so it makes a little bit more sense as we really get into it. So the first thing I mentioned is a Kubernetes operator. I believe I mentioned that on the previous slide. A operator is software that's going to extend the Kubernetes API. And this means that it's going to add new things that Kubernetes understands. By default, in a Kubernetes cluster, it knows about pods and deployments and services and resources like that. What operators do is they add custom resources. You define, it's called custom resource definition, that you deploy in, and now there are custom resources that you can deploy into a cluster. And you'll see this. We're going to be actually deploying, for example, by default, Kubernetes isn't going to know about any of these other terms that we have, a KubeVirt, a VM, a VMIRS. A default cluster will have no idea what that is. But by installing KubeVirt, we're going to be not only registering these new types with Kubernetes, so we can ask for a VM, but we're also going to be installing things into the cluster that know how to react to the request for a VM. And that's kind of what an operator is you extend the API by adding new endpoints and adding a handler behind that endpoint that knows what to do. So we'll see that as we dig in a little bit further. KubeVirt. KubeVirt is going to be an overloaded term because by default, it's the name of the project itself that we're dealing with. But in the context of what we're about to get started on and work on, it also is the name of the base resource that we're installing into the cluster. And so an instance of this thing installed into the cluster is going to be called a KubeVirt. And so it's both the name of the project and the name of the thing that we're installing. Not much different, actually, than if you're familiar with the Prometheus operator, how there's Prometheus, the tool, but you register and ask for a Prometheus in your cluster, and you get one. So very much like that. A VMI is going to be a virtual machine instance. You can think of this as the lowest level resource that's generally going to be managed by higher level resources, like the two below it, VM and VMIRS. You can think of it a little bit like a pod in the container world. So the same way a pod is like the lowest level resource for containers in Kubernetes, a VMI is the lowest level VM resource that's managed usually by higher things. But to be clear, pods still exist in the cluster, and pods are even still going to be used. That's just a parallel. VM is going to be a thin wrapper around a single VMI. So it's going to manage the state of the VMI and make sure that it's running, try to bring it up, and if it fails, whatever. It's also going to identify the VMI as unique. And so you can think of a VM resource as a little bit like a single instance stateful set. For those who are familiar with Kubernetes resources, it's like a single instance stateful set. The last one is a VM instance replica set. This is an arbitrary wrapper or arbitrary set of one-to-many VMIs. So it's more like a deployment. You know, a VM is like a single instance stateful set. A VMIRS is like a deployment where you have an arbitrary number that can scale in and out, and they're not unique. They're like cattle. And so we're not going to be using the VMIRS instance replica set today. We're just going to be using VM, and as a result, the VMI. So the last thing actually I'll mention is we talked about taints and tolerations. Actually, you know what? We'll talk about that a little bit later when we actually get into it. For now, let's jump back into the console. Okay, good. So provisioning is completed. That means that we should now have an actual bare metal node. And so let's actually bring up a terminal right here. And I'm currently hooked up to be able to talk to this Kubernetes cluster. So let me do kubectl get nodes. Actually, let me make this text just a little bit bigger in case it's small for people. And there we go. We've had one up for 2 minutes and 34 seconds. This is perfect. This is going to be our bare metal instance. So we are good to go. Okay, so let's go ahead and actually start installing KubeVirt since we have the bare metal nodes. So the first thing that we need to do is install the operator. Now, I'm going to actually kind of go through what it is that we're doing here. So I'm bringing up VS Code. This VS Code is looking at the, I believe it was the second link, or no, it was the first link that I sent out, which is the GitHub repo with all of the resources. And that's what we're looking at right now, is all of the resources. You'll see that there are two directories. There's bundles and there's manifests. At first, we'll jump into the manifest. For those who aren't using MassDriver, you can stay purely in the manifest directory. For those who are MassDriver users, or if you're interested in MassDriver, you can check out the bundles where we actually wrap everything up and make it even easier to deploy. And that's what we're going to be using here in the webinar. So the first thing that we need to install is actually the operator. So let's take a look at the manifest for the operator. The main thing that we actually care about here is going to be the custom resource definition, and we're going to be registering a KubeVirt, and you'll see this here momentarily. This whole file was not written by me. You can download this from KubeVirt's Git repo. It's part of their release artifacts. There's not a whole lot else to see here. What is a bit unique is that this is actually going to be the only custom resource that's installed. There will be other custom resources that need to go in, like VM and VMI and VMIRS, but the operator doesn't install those. What's interesting is when you install the KubeVirt, your first instance of this, all of those new API things get registered, which is kind of a unique pattern. That's not, for example, how the Prometheus operator works. But so for that reason, all that we have here is basically copy paste from the Git repo. Now, if we look at the bundle for the KubeVirt operator, we've just wrapped it in a Helm chart, and that's actually just to make it a little bit easier for us to use. We have the KubeVirt operator here. Again, there's not a whole lot to it. I think all we've added that's configurable is the namespace. And so let's jump into our terminal. I'm actually going to CD into the bundle and Kate's KubeVirt operator directory, and we're going to mass bundle publish. So we're going to publish that bundle since we're deploying this to Massdriver. We're going to publish it to Massdriver, and then we're going to jump into the terminal so we can go and deploy it. So let's go back into Massdriver here. And let's open up the bundle sidebar. And if we search for KubeVirt operator, there it is right there. So this is what I just deployed. Now, if I drag this onto the canvas, we'll just name it operator. Our system will automatically detect dependencies and fulfill them. So it's going to be installed into this Kubernetes cluster. Let's configure it. Again, the only configuration option here is going to be the namespace to install all this in, and KubeVirt is the perfect namespace. So let's just click deploy, and that's going to send off and start deploying. Now, this is going to take a couple of minutes to deploy. So let's again jump back into the slides, and we'll talk about what exactly we're deploying and how KubeVirt kind of works. So how does KubeVirt work? First of all, this image right here, I didn't build this. This is borrowed from the KubeVirt documentation. The orange icons are going to be the main things that we care about. All of the blue ones are things native in Kubernetes. The orange things are going to be things that we're installing. So right now, we're actually not really installing anything. We're extending the API by adding a KubeVirt resource. And we might be installing the controller. I think, though, this may actually even come with the when we deploy an instance of the KubeVirt. The control plane, though, is really going to be these. You can think of it as like these three pieces. Less so even the daemon set here. But the controller and the API are going to work together so that when you ask for things like VMs, VMIs, VMIRS, the controller, the API is going to register it and handle it and hand it off to the controller, who's going to be checking on the status of everything. So those two pieces are going to be working in concert to keep your systems up and running. Additionally, there's a Virt handler that gets installed as a daemon set. Now, a daemon set is going to be something that runs on all nodes, or at least a subset of the nodes. So unlike other resources where you say, I want 3 of them or 2 of them, or to auto scale them, a daemon set usually is going to be system components, like a logger, a log aggregator, or something like that. It's going to run every node that it needs needs to run on, and generally will also interface with the node itself to do things. And so Virt handler is going to need to run on all of the bare metal nodes. It doesn't need to run on the non-bare metal, but it needs to be wherever VM workloads could potentially be scheduled. So that's what the Virt handler is. Then that last one, this Virt launcher, this is going to be whenever you actually ask for a VM. Virt launcher is going to be part of the process of bringing up and managing and running the VM itself. So this is also what's interesting is Kubernetes, or KubeVirt, uses Kubernetes to help manage some of the VM resources. So it's not like either or. It actually is using, in terms of containers or VMs, it's using containers to help manage VMs. So we jump back. Hopefully we're deployed. We are. It's fully completed. So if we jump into the terminal now, what we should see if we do kubectl API resources is we should see KubeVirt. So this is what we just installed. We installed KubeVirt, and if we kubectl get all in the KubeVirt in the KubeVirt namespace, you'll see we have the operator that's running there. So that was the component that was installed. And so the operator is done. Now we can actually create a KubeVirt to kind of move forward with this and get a VM up and going. So let's jump back into the code now. Let me clear this. And we're going to jump back into VS Code. Okay, so we've installed the operator. The next thing that we actually need to install is an instance of KubeVirt itself. So this is, again, a beginner level webinar. So we're not going to be getting into the details of all these settings, but I am going to talk about a few of them that are, I would say, fairly important even at the beginner level. So again, most of this content comes from the KubeVirt tutorial I linked. I think it was the last link that I sent out at the beginning of this. You'll notice that the kind here is a KubeVirt, which 5 minutes ago we wouldn't be able to install because our cluster had no idea what it was. Now we can install it because this custom resource is now registered. The other thing to note is it's these two sections, one of which is actually commented out. There's an infra section and a workload section. The infra section is going to be like the control plane for this KubeVirt instance. This stuff does not need to run on bare metal nodes. These are going to be pods, containers that are going to be orchestrating things. And so if you're looking to save money, you should consider running that on like cheap T-based nodes, which is what we're going to be doing. The workloads, however, do need to run on the bare metal nodes. And so what is important is this node placement section and node selector and tolerations. What we're doing here is determining where workloads are going to go. And we're doing that with two things. One is node placement. This is saying which nodes to look for to try to get placed on. And you see we have that on both of them. The other piece is actually tolerations, which you'll see, or sorry, we don't actually have the node selector on the infra. We just have the tolerations. The tolerations are with nodes. If you remember on our bare metal nodes, we added a taint to it. And that taint was just VM equals true. And what a taint does is it taints a node so that workloads can't run there unless they tolerate that taint. And this is so that a great example is like GPU or bare metal based workloads. You don't want non-GPU workloads to land on GPU nodes that are very expensive. So what you do is you taint the GPU nodes and then you give GPU workloads a toleration of that taint so that they can run there. Right? And we're doing the same thing here where we've tainted our bare metal nodes, but our workloads need to have a toleration of that taint so that they can run there. And all the other workloads that don't tolerate that taint will not be able to be scheduled there. The other piece that we do is not only do we say you can tolerate those nodes, we tell it you are actually selecting those nodes. You want to run there. And so it's kind of it's a dual thing. We're telling it to run there and we're giving it permission to run there effectively with both of these things. This toleration isn't necessarily required. Part of the reason this is here is in that KubeVirt example, they actually tainted both the the infrastructure nodes and the bare metal nodes. And in our case, I don't do that. I taint the nodes that are kind of specialized and I'm leaving the nodes that aren't. So there's no taint that needs to be tolerated on for the infrastructure nodes. They won't run on bare metal simply by virtue of not tolerating the VM taint, right? So if you are deploying this yourself, you're going to need to copy paste the values in here to fit however you set up your environment. You know, whatever taints you've added and whatever the node group name is for the bare metal nodes, you're going to need to update those here before you deploy. If we look at how we're doing it with the bundle, this is actually what's really cool. If you look at our the Terraform, we're actually using Terraform in this case. I generally don't recommend using Terraform to manage Kubernetes resources, but one of the really cool things that we can do with Terraform is we can actually look up the node group that we tell it to run on, and we can extract out not only the taints, but also the node selector so that we can dynamically set those things and not have to copy paste anything. So this is one of the really cool things about using bundles and things like that, is you can automate some of these things that you used to have to copy paste. And so let's see how this actually works. This publishes bundle, so it's available. So let me cd up to the Kate's KubeVirt instance. We'll run mass bundle publish again. Perfect. Now let's jump into the mass driver console. And over here on the side, if instead of operator, if we go instance, you'll see we now have the instance here available. So I'm going to drag that out onto the canvas. We'll just name this KubeVirt and submit. If we then go in and we look at the configuration that's available on this bundle, you see that we have the namespace, which KubeVirt is fine again, but we have this node group name. And so this is where I can say, if you remember over here in this EKS cluster, the bare metal was named just metal. And so if I tell it that the node group name is metal, and I click deploy, what's going to happen is we're going to be able to inspect that node group, pull out any of the taints, and be able to infer the label of that node and be able to properly and dynamically set the node selector and the taints on it, which is really cool. So this is going to install into the cluster. It's going to create a new KubeVirt, which is going to have other resources installed in it. But the other thing that's really cool is it's going to actually register new API types as well. So let's pull up and let's actually watch what's going on here. So if we do kubectl get pods in KubeVirt, we should see, hopefully, whoops, let me watch that. So hopefully we see there, we just saw one thing come up. That was a job that is completed. Now it's terminating. And now we should see, I believe there's going to be an API that's going to hopefully be coming up shortly. There it is. Two of them, actually. Two instances coming up. And hopefully they will go ready here momentarily. And then once they're ready, we'll be able to move ahead. Now, the other thing, as this is coming up, since they're running, one thing I can also do is kubectl get pods in KubeVirt. Can't spell KubeVirt. I'm going to do -o which is going to also give us the nodes. And what you'll see here, I was actually just a little too early with this virt handler, because what you're going to see is all of these other ones, the API, the controller, and the operator, are all going to be running on T-based nodes. If I run them again, let's see if, and this virt handler here is going to actually be running on bare metal nodes, which is interesting. You'll see 163 and 221 if we do kubectl get nodes. There's three of them, and so if I were to describe the let's say I'm just going to describe this one, the 188 node, or sorry, this 248, this guy. If I do kubectl describe node, we'll see that this one is actually the bare metal node. If we scroll all the way up, goodness, it's got so many things. This is what KubeVirt does. It adds all of these labels onto it, so it understands what resources are available. But you see, this is the C5 metal node. So that's the only C5 instance that's running. So all of the infrastructure, the reason I point this all out is all of the infrastructure pods got scheduled on the T-based nodes, which is what we want. And then the daemon set, the virt handler, got scheduled on the bare metal. So that's exactly what we want. The other thing is if I do kubectl API resources, you'll see now that we have more API resources than we did before. Previously, we just had KubeVirt, and now all these other things have been installed as well. The VMIs, VMIMs, the VMI presets, all of these things. And so these got registered when we installed the KubeVirt instance. So we're ready to go. We've installed the operator. We've installed the KubeVirt. We're actually ready to create a VM now. So let me clear this. Let's jump back into our VS Code and let's look at the manifest for deploying a VM. Okay, this is it right here. So again, most of this has been just copied from the KubeVirt tutorial. I'll just point out a few things that I think are interesting. One is let's see, where's the image? Down here. The image here is going to be Fedora. Now, there are other images available, CentOS and Ubuntu, and you can create your own images if you want to. In this case, the default is just Fedora, so we're going to be using Fedora. You'll also notice we still have the same toleration and selector, and this has to be set up the same way as the workload stuff was set up in the KubeVirt instance. So we need to make sure we're selecting in the node selector, we're selecting the bare metal node group, and in the toleration, once again, standard DevOps, you got to copy paste the right values in here to be able to tolerate the taint that you've placed on your bare metal node. I have commented out the SSH section. You can set up SSH keys to be installed at VM into the VM at boot, so you can SSH into the instance. But I'm not going to be doing this because it's actually a cooler way, I think, to be able to get in and access this VM, which we'll see that a little bit later. So let's see what we're doing in the bundle. If you're using manifest, this thing can be modified and deployed as is. If we go and we look at the VM, we open the source, you'll see we're using Terraform again, and it's because we're doing the exact same lookup to dynamically set the taints in the node selector, or the tolerations, I should say, in the node selector. But what's also really cool is we can make the image, and we can even make the resources. I forget where the resources were, right here, and make the resources configurable, and we're going to see that. And this is really the power of bundles, of being able to make things configurable through a UI, or be able to auto-configure through automation, like we're doing with the data lookup and setting the tolerations. So let's publish this again, and then let's jump into the console and deploy it. So if I go back to Kate's KubeVirt, I think it's VM, yeah, mass bundle published. Excuse me. Okay, let's go into the terminal again. So that's been deployed. Now let's open up the sidebar and let's look for a VM. Here it is. Let's drag it onto the canvas. We're just going to name this VM. Perfect. Let's drag this up here so it's a little more in the frame, and let's configure it. So this is what's exciting to me about what bundles allow you to do is, once again, we can just say metal here for the node group and dynamically set the taints in the node selector. We can also change here. We could actually change this to Ubuntu or CentOS if we wanted, or whatever whatever image we want, and we can dynamically set the cores here. So let's say it just needs 1 CPU and 2 gigs of memory, and let's click deploy. Now this is going to deploy it out. Now what's really cool, again, to go back to that, is what MasterDriver is going to allow you to do is set up all of these resources so that they can be deployed by anybody. You see in each of these things I've answered, 4 questions or less. There was no configuration in the operator. It was only setting the bare metal node group name in the instance, and then the bare metal node group name, the image, and the resources. These are all things that, for example, developers would know if they need to deploy a VM. And so you can kind of set up all the complicated configuration and bake it into the bundle via automation, or expose the configuration that should be known to the user and available to the user, and allow them to be able to configure and self-serve whatever resources they need. And so that's what you get to see us doing here with MasterDriver. So let's check on this as it's coming up. So if we do kubectl get VM in KubeVirt, we should hopefully see it in there, and it's running. So let's actually check VMIs as well. And that also says it's up and running and it is ready. So we're actually running. This is a VM now that's running in our Kubernetes cluster on that bare metal instance. So we actually do some cool stuff with it now. We're going to use KubeVirt actually has its own CLI. It's called virtctl, and so we're going to be using it. If you run virtctl, you can see a list of a lot of the commands that it can do. So you can start or you can stop the VM from here. You can pause or unpause it. You can port forward to be able to access it locally. You can migrate. You can SSH or SCP into it. A lot of really cool stuff and even complex stuff that you can do from here. The one we're specifically going to do, since we didn't implement SSH, we're going to use console, which is going to get us a console a bit like SSH into the VM. So we're going to do virtctl console, the VM name, which is right here, KubeVirt demo VM. And again, it's in the KubeVirt namespace. Just like that, it's going to tell us the escape sequence, which is very strange, is control bracket, closing bracket. But if we hit enter, login information, at least for this instance, is just Fedora, like that, and we're in. So we're actually on our running VM right now. If I do who am I, who am I? You'll see we're the Fedora user. If I cat etc OS release, you'll see all of the information about this instance. And of course, you can then do whatever you want to in here. You can install the things that you want. You can configure it. You can bring up your web server, whatever you want. So there you go. Let's go ahead and I'm going to exit out of this terminal and we're going to wrap up this webinar. So let me jump back into our slides. There we go. So what do? We talked about KubeVirt, went over briefly what it is and why it would be useful. We technically modified a EKS cluster to have bare metal nodes and applied a taint to them to make sure that only VM workloads would run on it. We deployed the KubeVirt operator so that we could register the KubeVirt resource with it. We then deployed a KubeVirt instance using that resource, which then registered all of the other resources that we need as well. And then we deployed the VM into that Kubernetes cluster using KubeVirt and running on that bare metal node. And we consoled into that VM. And we did it all, at least we talked about it in terms of the manifest, but we did it all through Massdriver and using those bundles. And we did it in a way now that's very easily reproducible by anybody, developers, other engineers, other operations people, however works for your organization. So that's everything I have for this webinar. So thank you for watching. If you're interested in in our platform in Massdriver at all, please come check us out. We're at www.massdriver.cloud. If you need to contact me, you can reach me via email. And if you're interested in the platform, please reach out and schedule a demo. We're also interested, if you have any other topics that you'd like us to talk about in any of these webinars, feel free to reach out. And we're always interested and want to give back to the community in ways that are helpful. So with that, I'm going to start shutting down this webinar. However, I'll hang on for just a couple minutes. If you have any questions, feel free to ask them in the comments, and I will do my best to get to them. So again, thanks everybody for joining today.